Assalamualaikum warahmatullahi wabarakatuh. Good morning. Thank you to Mrs. Vera Ferdian Escom, who took the time to attend our ISIS presentation this morning. Before starting the presentation, I will introduce our group members. Introducing, my name is Fahmi Alamsyah Nugroho, and my colleagues Abdurrahman, Awaludin, Yasuhide, Nasution. What is deadlock? Deadlock is a condition where a process is no longer running or there is no communication between process in an operating system. Deadlock is a condition in which two more processes wait for another process to release the process that is currently in use. Because several processes are waiting for each other, there is no progress in the work of this process. What causes deadlock? The cause is come from sorts that are used repeatedly with many using main memory. There are four conditions. First, mutual exclusion. Mutual exclusion is the only one process can use the resource, and the other process that want to use the resource must wait until the resource is released or not. If one process and another process access in the resource currently, it will wreak havoc on the OS. Second, halt and wait. Halt and wait is a condition in which a progress that use a resource can request a resource again, meaning it wait until the request resource is not used by another process. This can cause resource starvation because a process may not know the resource for a long time. Third, no preemption. No preemption is a condition in which the resource in a process should not be taken for granted by another process. To get the resource, it must be released first by the process that hold it. Besides that, the entire process wait and only allows the process that has the resource to run. Fourth, circular wait. Circular wait is a condition in which progress is waiting for the resource, which is held by a second process, which is also waiting for the resource held by a third process. It will continue until the last process and the first process. The create is a circular chain. Deadlock handling. There are four general ways to handling deals with the deadlock issues, namely, first, ignoring the deadlock, second, deadlock is prevention, third, avoiding the deadlock, and fourth, deadlock detection and recovery.
First, ignoring the deadlock. Ignoring the deadlock means pretending nothing happened. This method is usually known as the ostrich algorithm. This seems to be doing something fatal, but the way the operating system handled deadlock by not detect them and letting them to automatically kill the program, so it feels like nothing is happening. Second, deadlock prevention. The use of prevention method is considered a clean solution from the point of view preventing deadlock. This method is used and approached by separating the four conditions that cause a deadlock to occur during execution. The first condition that can be separated is mutual exclusion. If there are no resource to specifically use for a process, there will be no deadlock. The second condition is to eliminate the hold and wait from waiting from another resource. Then deadlock can be prevented. The third condition is to eliminate non-preemptive, and last condition is to eliminate circular wait. Third, avoiding the deadlock. The deadlock avoidance method is used by the operating system to check whether the system is safe or not. This method checks every step performed by the operating system. Each process continues its execution until the system is safe. Once the system enters an insecure state, the operating system must take a step back. And last, deadlock detection and recovery. Deadlock detection and recovery in this method are detected first by using a several algorithm from the resource allocation graphic. This graphic is mainly used to represent the allocation of various resources to different processes. After detect a deadlock, several methods can be used to recover from that deadlock. So, the conclusion that can be drawn from the explanation above is that the deadlock are unwanted and strength system condition. Various variable conditions can cause a deadlock and as consequence make it very complex and difficult to prevent. Recovering from a deadlock also has its challenge, mainly because it is difficult to restore the system to something similar before the crash. To deal with internal processing, there are several formal methods through resource path and state diagram, which to some extent can predict deadlock. However, limit its appearance completely requires a solid design operating system along with highly efficient sync algorithm. So, that's all for the ESA's presentation this time. Thank you the attention of Miss Vera Ferdian as the examiner. Sorry if there are any mistakes in this presentation. Wassalamualaikum warahmatullahi wabarakatuh. Bye bye.